Hello, everybody. Today we're going to do some optional review problems to help prepare you for the imminent quiz. Problem number one, we want to write the equation of an ellipse, and we're given some information about some points on it and the foci as well. So how I would start this problem is I would plot those points because that's going to show you a lot of important information. It's going to allow us to find our center, our A value, and our C value. So we've got our points plotted, and the center has to be directly in between these points. It's going to be perfectly centered in the middle there. So if you look at the distance between these points right here, go over 1, 2, 3, 4, 5, 6, which means the center is going to be 3 away. So the center has to be at the x value of -3 right there. So I know that my center is at -3, comma, 7. Everything is in line with the same y value, which tells me that this ellipse is horizontally oriented. So what do I know at this point? Well, I know from my center out to my vertex is my A value. So how far out is that? Well, I've gone from -3 out to -8, so my A value is 5. What else can I figure out? Well, I know from my center out to a focus is my C value. And so from the center to that focus is a distance of 3. So I know my C value is 3. And from that information, I can figure out my B value. So I know that the connection between A, B, and C is a Pythagorean relationship. You might not be remembering what is going to be on the side by itself because it's not always what you think it might be. So what I do is I remember that in any Pythagorean relationship, the largest thing needs to be by itself. And if you know a little bit about ellipses, you know that A has to be the largest piece. So A has to be the one by itself. So this equation has to be 5 squared equals B squared plus not C squared, because I know C, so let's say 3 squared. So 5 squared equals B squared plus 3 squared. I look at this and I recognize that this is actually a 3, 4, 5 triangle. If you know the hypotenuse is 5 and you know one of the legs is 3, then the other leg has to be 4. You could also just solve it. 25 minus 9 equals B squared. So square root all that to get B. 25 minus 9 is 16. Square root of 16 is 4. And so we got B is 4. That tells me from that point I need to go 4 up and 4 down. So I can do that. I can go 4 up, 1, 2, 3, 4, and 4 down from the center as well, and plot that to get those covertices. So I've got all those points plotted, and now I can sketch in the shape of this hyperbola. No, this ellipse, I should have said, to the best of my abilities. And that looks pretty darn good. Looks like a little piece of poop because I've done it in brown. But we're going to accept that. It looks pretty decent. So we've done D. We've graphed it and we've shown all the important pieces. Let's find the eccentricity. So apparently we're doing this problem backwards. What is my eccentricity? Well, remember how to find the eccentricity. It's ECA. Yeah, it's defined as C divided by A. So my C value is 3. My A value is 5. So my eccentricity is 3/5. And remember, that's just a ratio that describes how circular or how elongated your ellipse is. So now all we have to do is write the equations. It doesn't matter which one you do first, rectangular or parametric. Let's just continue doing these backwards. We did C, we did D, we did C, so let's do B now. Let's do rectangular form. So x minus the x value of the center is -3, so x plus 3 squared. Honestly, let's do this though. Let's not do that. Let's say over my A value of 5 squared. How do I know 5 goes with the x? Well, 5 is how far I went left and right from the center to get to the vertex. So that stays with the x. Notice I've put the entire fraction in there, squared. I think it's going to make it easier to go to the parametric form. Then let's do plus. We'll have an entire fraction squared here. Y minus our y value. Our y value is 7, so y minus 7. divided by our b value, or if you don't want to think about it in terms of a and b, how far up did you go from the center? Well, you went up 4 to hit that ellipse, so we'll have a 4 down there, and it is equal to 1. So there is our rectangular equation right there. We've done b. So one more to do, a parametric form. Now we need to remember that to come up with this parameterization of an ellipse, we used the Pythagorean identity, which uses sines and cosines. So just like the unit circle, let's match up cosine of theta with x. Let's match up sine of theta with y. And then the coefficient on the cosine. The coefficient on the x expression is just how far you traveled in the x direction. And how far did we travel? We traveled 5 to get to those vertices. How far in the y direction did we travel? Well, we traveled 4 up and down from the center to get those co-vertices. All we need to do now is add the center values. What's the x value of the center? It's -3, so 5 cosine theta minus 3. What's the y value of the center? It's +7, so 4 sine theta plus 7, and we have shown everything we want right there. Yay.